Students, today we are going to revise force and laws of motion because we have already finished the chapter, but revision is equally important. So today we are going to just revise the chapter, whatever topics we have done, whatever main points of the lesson are there, that we are going to learn today. So the first topic that we had learned in this chapter was balanced and unbalanced forces. Then we had learned first law of motion. Then the topic was inertia and mass. Second law of motion. There are a few more topics, third law of motion, and also we had learned conservation of momentum. So these are the main topics of the lesson, force and laws of motion. Now let us see what are the important points or points to remember of this lesson. The first point, which is very important, and this is from where the mechanics starts, Newton's law starts, and that law is first law of motion. It states that an object continues to be in state of rest or of uniform motion along a straight line unless acted upon by unbalanced force. So unless and until an unbalanced force is acted upon an object, it continues in its state, whatever may be the state. It might be a rest position or it might be a uniform position. The natural tendency of object to resist a change in their state of rest or uniform motion is called inertia. So this resistance of an object, which is its natural tendency, and resistance for what? Resistance for change in its state of rest or uniform motion. It means that suppose there is an object and if you try to move it, then it will try to resist you. Or if the object is in uniform motion and you try to stop it, then it will try to resist you. This resistance is called inertia. Force of friction always opposes motion of object. This is a natural tendency of force of friction. It is always in opposite direction to the motion of the object. Then comes second law of motion. Second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force and it is in direction of the force. So rate of change of momentum, mathematically you can write it as dp upon dt. So difference in momentum divided by difference in time, or you can say derivative of momentum with respect to time, is proportional to applied force. So the general relation of force, which is force is equal to mass into acceleration, is actually derived from second law of motion. Now it's time for third law of motion. Very famous. To every action there is equal and opposite reaction and they act on two different bodies. So that is a complete definition of third law of motion. First line is very famous. To every action there is an equal and opposite reaction. Well, let us see next points. In an isolated system where there is no external force, the total momentum remains conserved. This is nothing but a statement of conservation of momentum. I repeat the statement. In an isolated system where there is no external force, the total momentum remains conserved. Now it's time for third law of motion. Very famous. To every action there is equal and opposite reaction, and they act on two different bodies. So that is a complete definition of third law of motion. First line is very famous. To every action there is an equal and opposite reaction. Well, let us see next points. In an isolated system where there is no external force, the total momentum remains conserved. This is nothing but a statement of conservation of momentum. I repeat the statement. In an isolated system where there is no external force, the total momentum remains conserved. Well, that was all for today. I hope there was a proper revision for you for this chapter. Please revise this point, see it again, because many times objective questions come from these important points. So please read it, and if you don't understand anything, feel free to ask me. Now, I have selected two questions, not from the textbook. You have to read about conservation laws. There are different conservation laws, and you have to read about them. You can use a reference book if you have, maybe H.C. Verma's Concepts of Physics, or Halliday Resnick's physics book Fundamentals of Physics. Its name is Fundamental of Physics. It's by famous scientist and writer Halliday Resnick. You can also refer any other book, or you can refer internet also if you have the access to it. So you had to read about conservation laws and write about it. You have to write about conservation laws in 150 words. Okay, and there is another homework for you. Write in brief about Newton's contribution to physics and mathematics. Okay, in brief. At the most you can write in 150 words. That is enough. 150 or 200 words. Okay, at the max 200 words. You have to write about Newton's contribution to physics and mathematics. We all know Newton, Isaac Newton, for his contribution in physics. That also you have to note it down. And also he has a big contribution in mathematics also. So he is equally important in both the subjects. So find out the information about him and write about him. Okay, so that was homework for today. Well, that was all for today. See you in next session. Until then, take care. Bye bye.